All right, so this is the greenhouse effect. And as I mentioned last class, without this occurrence, Earth would be so cold we wouldn't really be able to live here. So the greenhouse effect is necessary for life to exist on Earth. The problem is that the greenhouse gases are in excess in our atmosphere, causing the warming to be excessive. So excess gas is more warming. So this is how it happens. These yellow rays, and I'm just going to label it in orange, right here, they're called ultraviolet rays. So when the sun comes down, UV rays come down from the sun. So this is our sun, and this is right here our Earth. And what do you think this pink is? What layer? No? Troposphere. Try to put in your head, the only thing ozone has to do with the greenhouse effect is that it's a greenhouse gas. That's it. It's not a layer, it's just a gas. And where is where is this ozone gas if it's a greenhouse gas? In the troposphere. All greenhouse gases are in the troposphere. As a matter of fact, everything that we talk about in terms of air pollution happens in the troposphere except ozone in the stratosphere, which has its own job, okay? So UV rays come down and naturally they are re-radiated. So you could write that here as a statement. UV rays come down and are re-radiated into space as, anybody know? Yes, heat, which are infrared rays. I'm going to change this to orange, that word, and right here, because I want to differentiate the rays, colors. So UV rays come down and are re-radiated into space as infrared rays. I'm going to change this to black, like regular text. And then add the word infrared. Whoa, I'll put this up here then. Now, what happens is there are these gases, as I mentioned before, in the troposphere that are called greenhouse gases. So I'm going to label one right here, and I'm just going to call it water. And of course, I'll make this blue because water is like blue, right? And these greenhouse gases cause these rays to be re-radiated back to Earth, warming Earth. You see it here? The rays are supposed to go out into the atmosphere higher and higher and higher and leave Earth because we know energy is an open system, so it eventually leaves us. But instead, it gets pushed back down to Earth, causing Earth to be warmer. So I'll add that to the statement. So infrared rays, greenhouse gases redirect infrared rays back to Earth, warming Earth. The greenhouse gases, it doesn't let it travel out, it pushes them back down somehow. Here's actually a really good diagram of solar rays coming down. So this first ray would be what? Coming down. So if I draw an arrow going this way, you know it's UV ray. Once it comes down, anything going back is what? Infrared, right? And then even though it's going here and bouncing back, why is it bouncing back? We know this must be a what? A greenhouse gas, okay? So what are these greenhouse gases? Anybody know? CO2. And it shows here as 56% because the majority of the atmosphere, or I would say the best way to say this is the number one abundant greenhouse gas is CO2. Another way to say it is it's pretty much our most gas of concern, okay? Because we are emitting so much of it into the atmosphere. What else is a greenhouse gas? Nitrous oxide. And I think that would be right. All right, whatever. Ozone, nitrous oxide, CFCs, what else? chlorofluorocarbons. Methane and, shockingly, water. I know. You don't only have to know what is the most abundant greenhouse gas, which we know is carbon dioxide. You have to know what is the most heat-trapping gas in order. So the answer would be number 1 is water, which is not even on here. So add water as the number 1 heat-trapping gas. Okay. Number 2 is actually these hydrocarbons. You don't really have to know, well, you're going to have to know chlorofluorocarbons and hydrochlorofluorocarbons, and any hydrocarbon, in a sense, is going to be your number 2 heat-trapping gas. Number 3 is nitrous oxide. Number 4 is methane. So to give you an idea, methane traps 25 times more rays than carbon dioxide does. Nitrous oxide, 298. I don't know what year growth, well, I don't know what those potential, just think of the numbers. It's a lot more. And look how big these numbers jump, okay? And water's even more. When did we start worrying about this? After what? Industrial Revolution. Yeah. Industrial Revolution led to the steam engine, which led to the burning of fossil fuels, which led to excess CO2, nitrous oxide, and methane, because of industrialized agriculture even, have increased in our atmosphere. So the reasons, and I just said them, agriculture, burning of fossil fuels, and deforestation. And these, I don't know what I was thinking when I made these big boxes, but the pictures are there. Should have just left the pictures out. How does agriculture affect any of these gases? What's your answer? Fertilizers. Produce what? Into the atmosphere? Nitrogen, okay? Because if there's excess fertilizer in the ground, it's harder for plants to take it in, so it's either going to run off or get processed in some way and be released as a gas into the atmosphere. What else does agriculture, tell me everything agriculture has to do with greenhouse gases.
Maybe like plowing and farming machines.
Why?
They emit gas.
So machines for industrialized farming will emit carbon dioxide, nitrous oxide, okay? What else?
Irrigation.
Awesome. So water. Irrigation systems we know are not really efficient. So water, instead of going down, gets evaporated, right? So it's in the atmosphere, which is a greenhouse gas. All right, and how does agriculture have to do with methane? Cows. Write that down if you didn't remember, because that's definitely a question on the exam. So cows flatulate methane, yes? Methane is released through that process. All right, burning of fossil fuels, it's responsible for everything. What can we say? And then how does deforestation affect any of these gases? Or greenhouse gases in general?
It releases nitrogen from the soil.
Okay, so nitrogen from the soil can be released. What else?
Takes in less CO2.
So less CO2 is absorbed from the atmosphere, so causing more warming because there's nothing to take it away. Good. Awesome. So here's my number 1 greenhouse of concern, which we already covered. And then here's my heat trapping potentials. And here's my cyclic patterns, which we talked about already. When did we talk about that? Yeah. More patterns. I just had a lot of patterns, apparently. Yeah. So these types of numbers do actually sometimes appear. Overall, you want to know that temperatures have warmed between 1 and 1.5 degrees, which seems minute, but it's a lot, okay? Records indicate near level in temperatures from 1800s to 1900, a rise, a slight decline, and then a rise. The pattern is very, very important to know. The pattern of Earth's climate is fluctuating, rising and falling, but overall, increasing, okay? So even though you see an up and down pattern constantly, it's still going higher and higher and higher and higher. So you have to know that, okay? Associated with global warming. What are they?
Polar ice caps melting.
Ice caps melting. What else?
Flooding.
Flooding.
Starvation.
Starvation. Or what's this? Do you see? Droughts. Okay, so extreme weather. I'm showing you two pictures. Write that word down so you know. It's linked to extreme weather conditions. I mean, we're experiencing it all the time, right? What's our weather like? 50 degrees one day, and then extreme weather conditions. Droughts, floods, hurricanes, poverty, like lack of food, because obviously if you have droughts, you're not going to have good water, excessive heat, yeah, and good, biodiversity threat. Decrease of some, but there's going to be a slight increase of others. Anybody know what? And at the end of the day, even if you have an increase in specific types of species, how is that linked to a biodiversity threat?
They have to like consume other species.
They have to consume other species. They don't have enough predators, right? So you're creating an unbalance in an ecosystem. So even if there's an increase in species, it's still a biodiversity threat because it affects the balance of the circle of life.